Hi everyone. So in this video we will try to control the drone from Rust first. Okay, because we need to set up everything that is linked to safety. Because once you have like your code base actually controlling your drone, it can be a little bit dangerous, right? Like I have like a 3.5 inch drones, so we will walk you through some like safety precautions first physically, and then in terms of like fail-safe on the flight controller. And then we will connect our computer to the drone and try to control at least one command. We'll try to have the throttle be commanded from the computer. So what you will need for that, so we will go through it with like Betaflight, which is like the firmware that is running in the drone. That's one of many. You have I don't know, Clean Flight, iNav, or those are from the same family. But you have Arduino Pilot and so on. So this will be like specifically on Betaflight. And you will see there are a lot of like little details that are very specific to that flight controller's firmware. What you will need to have too, so need to be able to, of course, to plug the flight controller through USB to be able to configure it, and we will go through that together. And also you need to have a header on one of your serial ports. So this one is connected to the serial port 4. It depends on your flight controller, so look at your documentation there. And I use this one because there is a plug there, so I can put it in or unplug it. And that will allow us to connect eventually to our companion computer that we will put somewhere like on the 3D printing mount on top of the drone. But for now, right, we want to develop and try stuff. So what we will do is we will use this, which is like a UART to USB adapter, right? So you plug USB-C on one side, and that's going to be UART, so ground like a TX-RX on the other side, and you plug that in straight to your drone. I can send you in the comments or in the description below what I use for this, but you can use like there are like plenty. What you need to be careful about is that I try to have one that have rates up to 1 million bauds. So I don't have any like latency linked to a crappy like serial connection, and we know that our like little computer can actually handle that, like handle 1 million baud, because like its console can do that, and that's how you debug your platform. So you'll need your quad to have its propeller removed. Please, this is mandatory because we will do like some throttle stuff, and if you make a typo or whatever, your drone's gonna fly in your room, and that's not gonna be pretty for your fingers or worse your face, right? So remove your propellers. We'll only try it here like empty, so we see how the throttle control works like this. Last but not least, you need a charge-up battery. Be careful, lipos. I almost actually killed one. Do not like to be under 3 volts. So you'll see in the code base how to monitor the current like voltage, or you can use your telemetry to actually know what is the cell voltage of your lipo. Especially on the bench, you can forget that after like few minutes those lipos can die. All right, I think we are all set up. The first thing you need to do is to go to Betaflight, connect to your drone, right? And check. Okay, that's my drone that is connected, right? if you are not familiar with Betaflight, that's just a configurator that allows you to set up your like various parameters in your quad. And what we will try to attempt is not natural for Betaflight. So you need to override some safety to be able to control your drone from your little computer, right? And so first, what you need to do is go to the CLI mode and do, let me try to find back the thing. Set this variable. So it's called MSP. Sorry, it's complaining because it disconnected. So that tells basically Betaflight that on MSP, which is called like the Multiwii Serial Protocol, which is the protocol between the drone and the computer, right? That's the serial protocol. We'll look into it. It tells which channels, meaning like for example roll, pitch, yaw, and so on, right? Which channels you are authorizing your computer through MSP to control your quadcopter. Basically, we will try to be the pilot, basically from our Rust code base, basically moving the commands of the drone. And for that, like it's a mask. So if you look at what a mask is, like quickly, right? It's a binary value by default. Like nothing is overridden, so it's all 0, 0, 0. It could be 0 or 1, right? And every single bit has maps to one channel, right? So I don't know which one it is. I think it's roll first, then it's yaw, then it's throttle, and or maybe it's no, sorry, it's pitch. It's yaw there and pitch there, or something like that, right? What I know is like the third bit is actually the throttle, and it means that in binary, if you have like 0, 0, 1, or more like 1, 0, 0, if you will, in the reverse order, this is basically 1, 2, 4, right? It's 2 power 2, means in decimal it's 4 in decimal, right? So that's the value we'll need to set here to say, you know what, you are authorized to only touch the throttle through that connector, through that little connector, through the MSP serial port. Okay, so you do that, and then you oh no, sorry, the syntax is actually equal for, right? And then you save, and you should be okay. And don't forget to save, otherwise you'll be in trouble. Okay. Now, what will when you come back to the configuration, if you connect, it will make you. So those are the modes of your drone, and you probably know them if you are flying a drone. One of the main one is arming, right? Like so I map that to this button, right? And I make my controller tell me what I'm doing, because like, yeah, when you have the goggles and FPV and so on, you might actually bump into the wrong switch. So I prefer to always have like an immediate feedback, right? And that's what you hear from the controller. So and that's cool for you because you can see what I'm doing, right? So this first button will arm or disarm, right? And you see something there. It is disabled by default. That's a safety when you are connected through MSP or with your like configurator. This thing, Betaflight forbids you to arm, because yeah, you can touch stuff and so on, and the only way to actually disable it is through this test switch. But we won't need it here, right? Because I'll show you something. Okay. Once we set up the masks for the channels to be controlled through MSP, it will actually you will have a new mode that appears. This one you never see it if your override it has 0. Basically, you never want to control your drone through MSP, right? And this MSP override, so be careful about the logic, right? Means that if this mode is activated, then MSP can control your drone and can only control the bits, the masks we set have been set on, right? So basically, that's if your thing. And you can map that, of course, to a control. I put that the third switch, right? So basically, I'm in auto if the override is set. So basically, I say, yeah, my computer can control the drone, but if I do that, it switch back to a normal control, right? And of course, like every single other channel, including arming, for example, should not be overridden by the computer, right? So even if you are like whatever mode, manual or not, if you disarm, it should actually disarm the quadcopter, right? Because sometimes, yeah, you are in panic. This thing is doing something completely crazy. You should be able to disarm like right away without thinking about am I in whatever mode and so on. So check that your setup is really matching what I've just shown you on the screen, right? Like that you have a button that can switch from manual to auto, and an arming feature that is completely independent that you can control over, right? So okay, that sets the setup for this. We can disconnect the configuration, and let's go and actually plug, instead of plugging it directly to the flight controller. Let's control MSP, but through our little interface. Okay. So that shows up as like a serial port, and when you look at the code base, for me it shows up at ACM0. It can vary, right? Like depending on whatever like type of interface you have, but for me it shows up like this. Oh, I forgot something to tell you. Sorry. Let's come back to the thing. Like you need to configure this port also on Betaflight. So let's go back and connect back, and on the ports, what you need to do on the UART, you want to be able to connect with MSP. You need to activate this one, MSP, and put the correct baud rate for your computer. We settled on 1 million, right? So we will continue on this, and that's it, right? You save and reboot, should be fine, and that allows you to do what I just did. Okay, and okay, so I developed a little program, right, that basically connects to this port. First, I wait for the port because sometimes I just I don't know, I just tinker on it and so on, and I don't want to have a kind of a race condition between me and connecting to the port, right? And then basically I ask from some so MSP has got some commands, right, like that are like, for example, the battery state. We talked about it, like to be able to monitor your battery, and it's a request response type of protocol, meaning that first you send a request that I implemented here, right? I basically serialize the packet and send that through the serial port. And I ask, oh, you know what? Give me the battery state, and then I will wait for a response. Can actually put that a little bit like bigger, right, for you, right? So I send here like like a request saying like it's just like a packet with like a conventional number, like it's 130 there, right? And then in a loop, I take the response, I pass the response also, and if I get the response for my battery state, I can actually print it and so on. So depending on what I want to print, I will comment out which one I want to see. And to test our little command, like we don't have like any autonomy working yet. So what I did is basically I built a kind of like a sinusoid, right? So you'll hear the throttle going up and down and up and down and up and down. So you know that's our computer that is controlling the throttle and not us, right? And we will test all those combinations of arming, not arming, and controlling it from the computer and changing modes and so on, right? And that's going to be our way of looking at what is going on the quad and confirming that all our safety features are working correctly. I print the state of the throttle like when at the bottom and the top. So those values, for those that are not like familiar with like the RC world, are conventional for 1000 is basically 0 and 2000 is 100%, right? So it's a convention. It goes back from like a pulse width modulation to actually actuate like real motors. But now it's kind of virtual, right? Let's say for you it's just a conventional range between 1000 and 2000 that you can normalize to from 0 to 1 if you want, right? So in that message I set the throttle that is actually making like a sinusoid. Then I serialize it, and then I send it with the correct command. I send the request through the serial port back to the drone. Then okay, some logging, and there I pass what is the state of the basically the RC, basically what we send through the remote command, right? And that helps us to debug, like, okay, if I move some channels, you see which one it is, and then you see the value, and it give us a little bit of feedback, right? And that's it, right? The thing I'm using, it's called Multiwii version 2, something like that, as a crate. I'll share the code base with you guys. But it's kind of lacking. It was also like allocating for every single message a vector, right? So that's not good to integrate that with Copper. So I will share with you my fixed version of it. It's very simple, really. It's really not that complicated, right? You have like structures that match the documentation for the protocol with fields in there, right? Depending on what it is, with their value. Often they are actually integers, and they are like derived from pack struct, which is like a crate that allows you to parse those kind of fixed structures very easily. So pretty cool. And you have like all the commands that are in this like enum that match all those, but you don't have like a matching between those messages and those command codes. So you need to do the matching yourself, like I did like there, right? Like I said, set raw RC, meaning like, okay, let me set the RC from the computer, right? But I had to use the correct raw RC, or like it's kind of like, yeah, raw like RC structure, right? So you'll need to match that. Maybe I'll fix that at some point, but I'm too lazy to do this right now. Okay, so let's first do like some like quick checks. So let's hook up the battery to the drone. Do that at the last minute because your everything is actually heating up. So if you don't have like a little fan, I bought one, but it's not arrived yet. Everything is gonna heat up like pretty quickly. So okay, seems to be happy.
Telemetry recovered.
That seems to be happy too. And so first, normally, if you are in manual mode and you're without like running any code, right, you should have the normal behavior of your quad, right? So first, for example, if you arm, okay, the motors go into idle, that works, right? And you can disarm, it stops. Cool, like the basics are, the very, very basic is working. Now let's start our little proggy here, right? She's still running, okay? So yeah, sorry for all the noise, but you see that if we are in manual, and if we change the throttle, you see it like its value increasing, like that number, like the 0, 1, 2, 3 index on the channels, right? You see, going down, up, and down. Okay, it means that we right now in that mode we do have control over that throttle. If we arm, you'll see that we can actually pulse the throttles ourselves, right? Okay, so that works. Now you see that that the computer is trying all the time, like if you look at that, like trying to actually switch, like pulse the throttle, but it doesn't do anything, right? If I keep in arm, it's continuous, right? There is no sinusoid, right? Now if I switch that to auto and arm, now it should pulse the throttle. And if you can hear me through the noise, because it's really bit noisy, you see that we have no control whatsoever on this one. But we still have the control on the other ones, right? You see the quad moving. Okay, let's stop this. Starts to, I don't know, touch something. It smells like burning something. So we'll keep it at that, right? Okay. Let's stop this and come back to the code base. So you've seen what we've did, right? Like basically we injected a command and we filtered out of the and control the filters to have those commands being fed or not in our drone. And yeah, I think that's it for this video. We went through all those setups, so we can be ready to integrate that to Copper and run that. That can be probably the next step. Run that on our little computer to see if we can control our drone. So thank you very much, wherever you are coming from, because you could have spotted this video from the RC world, like where you want to actually be able to control your drone, or from more the robotics world. So if you want to follow along, right, the goal of this series is to actually make a computer fly this drone and kind of almost autonomously, right, like actually observing the world and like reacting to it, like through those like tags, right, and through the Copper runtime, so the Rust runtime, the Rust robotics runtime. Thank you so much, and see you around.